Ratios are a comparison of two numbers using division. And proportion is just an equation stating two ratios are equal. Bless you. Okay, so a proportion is going to look something like this. Yesterday I asked you, that looks really tiny, let me rewrite that. Example. I asked you to give me an equivalent fraction to 3/5. That was on your paper yesterday. What is an equivalent fraction of 3/5? What? 6/10. How did you get there? Yeah. Right? I just multiply 3 times 2 and 5 times 2. Right? Those are an equivalent fractions or a proportion. Right? So I have this little picture right here. We've got globes and I have maps. How many total navigational items do I have? Yes. How many globes and maps? So for every 2 maps, how many globes are there? Yeah. How'd you figure that out? Yeah, so if I divided 4 by 2, then I'll divide 6 by 2 to get 3. Cool. So we can write ratios in a bunch of different ways. We can write them out, right? So we could say something like maps to globes. Or we could say 2 to 3. Or even something like 2 for every 3. Or we can write it in what's called odds notation. So it looks like this, 2:3. And you read it same way, 2 to 3. Or we can use fractional notation, which looks like a fraction, but really it means something different than a fraction does. Fractions are looking at a part over a whole. And that's just one number, right? 2/3 of something. We have a pizza and we're looking at 2/3 of it. It's a little wonky, but that's okay. It's still just one pizza. We're just looking at a part of the whole. Versus a ratio, which is again comparing two numbers. Right? So looking at 2 purple pizzas compared to 3 blue pizzas. I don't know why you would eat a purple or a blue pizza, but you get. But a purple pizza? Have you guys ever had the purple ketchup before? Yeah. Yeah? Okay. Blue? Yeah, exactly. Again, I will. Yeah. Like a tie-dye pizza, that would be cool. Anyway, So we can compare quantities 3 different ways. So we can look at a part compared to a part. So think about, right, our 4 maps to 6 globes, right? We're looking at the part compared to the part. Or we can think about a part compared to the whole. So 4 maps to, what was the total? 10. Yeah, so to 10 total. Or you can do it the opposite way. Look at the whole compared to the part. So 10 to 4. So 10 total to 4 maps. Okay. And the thing that is important to remember is talking about order. So you have to keep things in the same order, right? So if we're looking at miles per hour, that's a ratio, right? We're looking at 65 miles per 1 hour. We wouldn't then want to say, well, now I'm running a 12-minute mile, 12 minutes to 1 mile. Now those ratios are wonky, right? You're looking at miles to time, distance to time, and then you think about time to distance. It's not going to compare the same way. You got to keep everything in order. Does that make sense a little bit? We'll talk more about it when we get into like the word problems, but for right now, just remember that to keep things in the same order. And then we can visually represent ratios in a whole bunch of different ways. We could look at a model, which is kind of like our purple and blue pizzas, right? So 2 purple things compared to 3 blue things. Or if you don't have colors to use, you might want to think about 2, yeah, shaded or not shaded, or different shapes, right? 2 stars compared to 3 squares, or whatever you want. So we can make a visual representation, or we can make, what was that, Damon? Or we can make a table. So I can say maps compared to globes. If I have 2 maps, I have 3 globes. So if I have 4 maps, how many globes do I have? And if I have 6 maps, excellent. I really hate this tape diagram, so just ignore it. But we will look at coordinate planes, because that's what we talk about a whole lot in here. So coordinate planes, right, are just looking at 2 variables compared to each other. So I could use a coordinate plane to represent a ratio. If I made my x-axis maps and my y-axis globes, and we go over to 2 and up to 3, and this point right here, 2, 3, represents 2 maps for every 3 globes, right? And then we can also use this little fancy double number line. So I'll make maps up here at the top, globes down here at the bottom. And again, if I have 2 maps, how many globes do I have? 3. If I have 4 maps, how many globes do I have? And 6 maps means what? 9. But 8 maps gives me how many, Daniel? 12. Yeah. Cool? It's okay? Let's flip over to the other side. And I'm going to do 4 of these problems with you. And then we'll go outside and finish up the rest. Bleep, 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 bleep. Okay. So there's a whole bunch of different ways to think about solving proportions. And you might want to use a different way than what I show you. As long as you get to the same answer, that is fine with me. There's a million different ways to get to the same place. But I'm going to show you just cross multiplying because it always, always, always works. So if I'm going to cross multiply to solve, multiplying across. 10 times 4 gives me what? And 6 times x gives me what? Excellent. So now I got to figure out what is x. What is the number that when multiplied by 6 would give me 40? How do I solve for x? Yeah, I got to get x by itself. So how do I get x by itself? Yeah, right, because I'm taking x, right here, I'm multiplying x times 6. If I want to undo that multiplication, I have to do the opposite of multiplying by 6, which is dividing by 6. So I divide both sides by 6. I get 40 over 6 equals, and I'm just going to write this kind of the same way as what we did yesterday. So I'm going to take those 6 over 6 times x. And what happens to those 6 over 6? Yeah, they just become 1. So over here on the right side of the equal sign, I just have x, and x equals 40 divided by 6. It is repeating. It ends with a 7 because your screen is not infinite, and it has to stop at some point. So when it stops at that last number, it's going to round it up because the next number is going to be another 6, right? So 6.6 repeating with that line over the 6, that's the most accurate way you can write that number. All right, for number 2, what are the 2 pairs of numbers that I'm going to multiply? Excellent. 5 and 5, 4 and x. What's 4 times x? Excellent. What's 5 times 5? Yeah. So now what do I do? Yeah, I divide both sides by 4. So now I end up with 4 over 4 times x equals 25 over 4. They become a 1, so what's left? Just the x. X equals 25 over 4, which is? Excellent. 6.25. Is that making sense? Yeah? Any questions so far? No. Okay. Let's do 2 more together and then we'll go out. So someone tell me what to do for number 3. What's 9 times 4? And now what? Divide by what? 3. Divide by 3. So now I've got 3 over 3 times a equals 36 over 3. What happens to my 3's? Yeah, they become a 1. So now I'm left with just a equals 36 over 3, 12. Good. Number 4, what do I do? Huh? 2 times x equals 6 times 9, 54. And now? Yeah, divide both sides by 2. So I get 2 over 2x equals 54 over 2. What's 2 over 2? 1. So x equals 54 divided by 2. Excellent. Right? Any questions? Feel okay on those? Excellent. So I'm going to need you to have this paper, your calculator, and a pencil. Before we leave, I want you to grab a clipboard on your way out. No way, did you find that paper from yesterday? We're going to go out to the front courtyard. Let me just call the office. Hello, we're going outside again. Thank you. Bye-bye. She knows now. Yes. She's busy, I'm busy. We just keep on moving. Water. No way. You got it? No. Okay. Give me just 1 moment. Someone grab the hall pass, please. Okay. You guys ready? We're going outside with it. Calculators, pencil, clipboard, and we can go. Going up to the front door. Please do not talk in the hallway.